students. So the next chapter that we will discuss is confocal conics. When do we say that a set of conics are confocal? So confocal means the set of conics which have same foci. Alright. For example, suppose this is a parabola and this is its focus. Then suppose all these parabolas also have the same focus. Then we say that this set of parabolas is confocal parabolas. So similarly, this is an ellipse and these are two focuses of this ellipse, alright, or foci of this ellipse. And suppose all other ellipses also have the same foci. Then we say that this set of ellipses is confocal ellipses. Similarly, we have a set of confocal hyperbolas, and this set of conics, these two foci are the foci of all these ellipses, and these two foci are also the foci of all these hyperbolas. So this set of ellipses and hyperbolas is also a confocal system of conics. So we have discussed, so obviously since the foci of a system of confocal conics is same, so their centers is also common. The center of all these ellipses would be the same point, and the axis is the line which is the join of the foci. So the axis of all these ellipses is also same. The major axis and minor axis of all these ellipses would be confocal ellipses would be same. Similarly, this same axis, all these hyperbolas and ellipses here have the same axis and have the same center. Alright, so the center and foci and the axis of the confocal conics remains this way. So first of all, we have this article. To find the equation of a confocal conic, which are to find the equation of a conic which are confocal with this conic. X square over a square plus y square over b square is equal to 1. Alright, so this is the equation of a conic, and we have to find the equations of all those conics which are confocal to this conic. Confocal means which have the same foci, same axis and same center as this conic. So we know that the coordinates of the foci of this conic are plus minus a square minus b square 0. These are the coordinates of foci of this conic. Alright, suppose x over a plus y over b, since any conic which is confocal to this conic, has the same center and same axis. So suppose x square over a square plus y square over b square is equal to 1 is the equation of any conic which is confocal to let's call it 1 to the given conic. Okay? Because confocal conics have same center and same axis, major axis, minor axis, or transverse axis and conjugate axis, and it have same foci. So suppose this is the equation of a given conic. Its foci, the coordinate of its foci are these. Suppose this is the equation of any conic which is confocal to this conic. having the same center and same axis. Alright, then the foci of this the foci of this conic would be, similarly you can write plus minus a minus b 0. Now since this conic is confocal to this conic, so they should have the same foci. So since the conics are confocal, implies the coordinates should be same. So that means a square minus b square root should be equal to a minus b, and that means a square minus b square should be equal to a minus b, and that implies a minus a square is equal to b minus b square. That means a minus a square should be equal to b minus b square, and suppose both of them are equal to lambda. Suppose both of them are equal to a lambda. That implies a is equal to a square plus lambda and b is equal to b square plus lambda. Alright, so this means this equation can be written as x square over a square plus lambda plus y square over b square plus lambda is equal to 1. Alright. So, what is lambda? Where lambda is a parameter. Where lambda is a parameter, parameter means it is a constant which can take values, different values. Alright. It can take many different values, infinitely many different values. So it is a constant, but it can take different values. That is called a parameter. So we have shown that if this is a given conic to us, then any conic which is confocal to this conic, its equation will be of this type. If this is the equation, if this is a conic x square over a square plus y square over b square is equal to 1, then the equation of any conic which is confocal to this conic would be x square over a square plus lambda plus y square over b square plus lambda equal to 1. Where what is lambda? Where lambda is a parameter. So this is the equation of any conic which is confocal to the given conic. Now we have another article. Which says that two members of a confocal system pass through a given point of which one is ellipse and the other is a hyperbola. Two members of a given confocal system pass through a given point of which one is an ellipse and the other is a hyperbola, and which cut each other orthogonal. So this is the article that we will discuss next. This article says two members of a confocal system, if you have a confocal system of conics, pass through a given point of which one would be an ellipse and another would be a hyperbola. What does it mean? It means this, that if you have a confocal system of conics. If you have a confocal system of conics, and you have any point, any given point x1, y1. If you have a confocal system of conics, for example, this is a confocal system of conics. Okay, you have many ellipses, a system of ellipses and hyperbolas. All of them have the same foci, same center and same axis. So two members of a confocal system pass through a given point. So if you are given any point, say you are given this point x1 and y1, first of all we have to show that two members of a confocal system pass through this point. For example, two members of a confocal system pass through a given point x1, y1. One of the members would be an ellipse. One of the members would be an ellipse and the other member would be a hyperbola. The other member would be hyperbola. So we have to prove that two members of a confocal system pass through a given point of which one is an ellipse and other is a hyperbola, and this ellipse and hyperbola we also have to prove that this ellipse and this hyperbola cut each other orthogonally. That means they cut each other at 90 degrees. That also we have to show. So how do we show that in this article? So let x1, y1 be a given point, and let x square over a square plus lambda plus y square over b square plus lambda equal to 1 be a confocal system. Suppose this is a confocal system, and suppose x1, y1, this confocal system passes through the point, alright, through the point x1, y1. So let a member of this confocal system passing through this point. So that means this point should satisfy this confocal system. That means x1 square over a square plus lambda plus y square over y1 square plus b square plus lambda is equal to 1. Alright. So suppose x1, y1 is a given point, and suppose you have a given confocal system. Alright. And suppose x1, y1 lies on this confocal system. So we have put x and y1 in this confocal system. This implies what? The lambda is a parameter. Okay, lambda is a parameter. So this implies a square plus lambda into b square plus lambda. If you take the minus a square plus lambda x1 square minus b square plus lambda x1 square minus a square plus lambda y1 square is equal to 0. Alright, this into this is here, minus this into this, minus this into this. Alright, so this implies this. So suppose x and y1 is a given point, and suppose you have a confocal system, and suppose x and y1 lies on this confocal system, then x and y1 should satisfy this confocal system, and that means you will get this equation. This is a quadratic equation in lambda. This is a quadratic equation in lambda. Equation in lambda. So this quadratic equation in lambda will have two roots. Let's call one root has two roots, lambda 1 and lambda 2. So this quadratic equation in lambda has two roots, lambda 1 and lambda 2. Let's call this part as f lambda, function of lambda. Let's call this part as f lambda. So this equation, this quadratic equation is f lambda is equal to 0. So this quadratic, alright, if we call this part as f lambda, then this quadratic equation is f lambda is equal to 0. So this quadratic equation has two roots. So if you solve this quadratic equation, alright, then you get two roots, lambda 1 and lambda 2. Putting lambda is equal to lambda 1 here, you get one one member of the confocal system, and by putting lambda is equal to lambda 2 here, you get another member of the confocal system. So that means two members of the confocal system will pass through the point x1 y1. So this part we have shown that two members of the confocal system pass through a given point. So if you are given a point, then two members of the confocal system will pass through this point, because this quadratic equation will have two roots, lambda 1 and lambda 2. But so by putting lambda is equal to lambda 1 here, you get one confocal system, and by putting lambda is equal to lambda 2, you will have another confocal system. Now we will show that one of the confocal conics, you will have one confocal conic, and by putting lambda is equal to lambda 2, you have another confocal conic. So now we will prove that one of those confocal conics would be an ellipse, and the other confocal conics would be a hyperbola. By putting lambda 1 and lambda 2, we get two confocal conics here. So we will show that one of those confocal conics would be an ellipse, and the other confocal conics would be a hyperbola. How do we show that? We show it like this. So you see that this part is f lambda. So f lambda is equal to a square plus lambda b square plus lambda minus b square plus lambda x1 minus a square plus lambda y1 square, x1 square y1 square. Alright. So if let's find its value at minus a square. What would be the value of f lambda at minus a square? At minus a square, this would be 0. This would be 0. So it would be equal to minus b square minus a square x1 square. We are supposing here, alright, we are supposing here that a is greater than b. Okay, we are supposing here that a is greater than. Okay, one of them is bigger, one of them is smaller. So we suppose that a is bigger than b. So a square is bigger than b square. So if a is bigger than b, so a square is bigger than b square. So this would be negative, and you have a negative sign here. So this means this is positive. So f of minus a square is positive, and f of minus b square. What is f of minus b square? F of minus b square, if you put lambda is equal to minus b square, this would be 0, this would be 0, and this would be minus a square minus b square y1 square. And since a square is bigger than b square, we are supposing that a is bigger than b. So this would be positive, and this would be, so this negative sign, this would be negative. So f lambda is positive at minus a square and negative at minus b square. F lambda is positive at minus a square, and that means one of the roots of f lambda lies between minus a square and minus b square. This implies one root of this quadratic equation, one root of this quadratic equation lies between minus a square and minus b square. So let's suppose that root, let's call that root as lambda 1. So let minus a square be less than lambda be less than minus b square. Alright. So suppose this happens. Let's call that root as lambda 1. Let lambda 1 be that root which lies between minus a square and minus b square. So this means what? This implies lambda 1 plus a square is positive. This implies lambda 1 plus a square is positive, and this implies lambda 1 plus b square is negative. So if this quadratic equation had two roots, lambda 1 and lambda 2, then putting lambda equal to lambda 1 here, you get x square over a square plus lambda 1 square plus y square over b square plus lambda 1 square equal to 1. So this would be one confocal conic, and which passes through the point x and y1, and putting lambda is equal to lambda 2, x square over a square plus lambda 2 square plus y square over b square plus lambda 2 square equal to 1. This would be the other confocal conic which passes through the point x and y1. So if so first of all we see that one root of this quadratic equation lies between minus a square and minus b square, and that means lambda 1 plus a square is positive and lambda 1 plus b square is negative. So if this is positive and this is negative, then this is the equation of a hyperbola. Alright, this is positive and this is negative, means this is the equation of a hyperbola. So this is the equation of a hyperbola. So one of the confocal conics which passes through x and y1, we have shown that two confocal conics pass through the point x and y1. One of the confocal conics is a hyperbola, and the other confocal conic we will show is an ellipse. How do we show that? You see that f of minus b square is, we have observed, is negative. F of minus b square is negative, and f lambda goes to plus infinity as lambda goes to infinity. When lambda is very, very large, f lambda goes to infinity. This is f lambda. Alright, this is, first term has lambda square, other two terms simply have lambda. So lambda square is bigger term than lambda. So lambda square is dominating term. So if lambda goes to infinity, then f lambda will also go to infinity. This is easy to check. If lambda goes to infinity, f lambda also goes to infinity. So that means f plus infinity is positive. Alright. So you observe here that f of minus b square is negative and f of plus infinity is positive. So that means one root of f lambda lies between minus b square and plus infinity. So suppose that root is lambda 2. So it lies between minus b square and plus infinity. It lies between minus b square and infinity. Because f of minus b square is negative and f of plus infinity is positive. So that means one of the roots of f lambda lies between minus b square and infinity. Also we have, since a is bigger than b, so a square is bigger than b square, and since a square is bigger than b square, so minus a square is less than minus b square. Since a is bigger than b, so a square is bigger than b square, that means minus a square is less than minus b square. So this implies what? This implies now minus a square, so that means a square plus lambda 2 is positive. You take this to the other side, that means a square plus lambda 2 is positive, and b square plus lambda 2, and both of them are greater than Yes, and b square plus lambda 2 is also positive. This is easy to see. You see that minus a square is less than lambda 2, so that means lambda 2 plus a square is 0 is less than a square plus lambda 2, and 0 is less than b square plus lambda 2. So a square plus lambda 2 is positive and b square plus lambda 2 is positive. So the other conic, in the other conic, a square plus lambda 2 is positive and b square plus lambda 2 is also positive, and that means this is an ellipse. That means this is an ellipse. So this is an ellipse, and this is, because here this is positive and this is negative, so this is a hyperbola. So one of the confocal conics is a hyperbola and the other confocal conics is an ellipse. So if you have a system of confocal conics, and then if you are given a point x and y1, then two confocal conics pass through that point, and out of those two confocal conics, one would be a hyperbola and the other would be a ellipse. That we have shown. So what was the article? Let's revise it once again. We have shown that if you have a system of confocal conics, and if you have a given point x and y1, then passing through that point x and y1, there will be two members of the confocal that system of confocal conics. There will be two members that would pass through a given point x and y1, and one of the members would be an ellipse, the other member would be a hyperbola. This is what we have shown. And now we will show that from a given point x and y1, if you have a system of confocal conics, then and you are given a given point x and y1, from that point x and y1, one of the confocal conics that passes would be a hyperbola, the other confocal conics would be an ellipse. We will show that they will intersect each other orthogonally. These two conics would intersect each other orthogonally. That also we will show. So we have to show that this is what we were trying to do. Which cut each other orthogonally. This is the other part that we have to show. The two members of a confocal system pass through a given point, of which one is an ellipse and the other is a hyperbola, which cut each other orthogonally. Now we will show this part, that two members would cut each other orthogonally. So let's show that. So we have shown that if you are given any point x and y1 and you are given a system of confocal conics, then from a given point x and y1 there would pass two confocal conics. One of the confocal conics would be an ellipse and the other confocal conics would be a hyperbola. Now we have to prove that this ellipse and this hyperbola cut each other orthogonally. Cut each other orthogonally means that at this point, if you draw the tangents, then the angle between these tangents will be 90 degree. We say that two curves cut each other orthogonally if at the point of their intersection the tangents are at 90 degree. So we have to show this thing. This we have already shown that if you have a confocal system of conics and if you are given a point x and y1, then from this given point two confocal conics would pass. One would be a hyperbola, other would be an ellipse. Now we will show that they cut each other orthogonally. So let x and y1 be the given point, right, from which these two confocal conics pass. One confocal conics is this, other confocal conics is this. So both of them pass through x and y1. So they should satisfy. So x and y1 should satisfy this equation. So this means x1 square over a square plus lambda square plus y1 square plus b square plus lambda square is equal to 1. And the other confocal, hyperbola passes through this point and ellipse also passes through this point. So that means x1 square over a square plus lambda 2 square plus y1 square over b square plus lambda 2 square is also equal to 1. So if you subtract these, you get x1 square into 1 over a square plus lambda 1 square minus 1 over a square plus lambda 2 square plus y1 square 1 over this minus this and 1 over b square plus lambda 1 square minus 1 over b square plus lambda 2 square is equal to 0. And taking this, you get x1 square over a square plus lambda 1 square into a square plus lambda 2 square. Alright, and what you get here is this minus this would be lambda 2 square minus lambda 1 square. There are no squares here, sir. There are no squares here. So this would be, this minus this would be simply lambda 2 minus lambda 1 and plus y1 square into this would also be simply lambda 2 minus lambda 1 over b square plus lambda 1 into b square plus lambda 2 equal to 0. So lambda 2 minus lambda 1 cancels through because lambda 1 is not equal to lambda 2. So this gives you x1 square into b square plus lambda 1 into b square plus lambda 2, alright, and plus y1 square into a square plus lambda 1 into a square plus lambda 2 equal to 0. So we have got this condition. If two members of a confocal system pass through a given point x and y1, then we have got this condition. Now we are going to show that these conics, this ellipse and hyperbola, they will cut each other orthogonally. So how we will show that? The point x and y1 is this point. At this point you find the equation of the tangent to this conic. Okay, that equation would be xx1 over a square plus lambda 1 plus yy1 over b square plus, no squares here, sorry, plus lambda 1 equal to 1. This is the equation of the tangent to the first conic. Similarly, you find the equation of the tangent to the other conic. To find the equation of the tangent to the other conic, alright, you will have, in place of lambda 1 you will have lambda 2 here, and then find the angle between these two. Then to show that they are perpendicular, and find the slope of this, tangent. The slope of this tangent is minus coefficient of x a square plus lambda 1 over b square plus lambda 1. This is the slope of the one tangent, and what would be the slope of the other tangent? The slope of the other tangent would be minus x1 over y1 b square plus lambda 2 over a square plus lambda 2. Alright, since alright, and these two would be perpendicular if the product of the slopes is equal to minus 1. If the product of the slopes is equal to minus 1, then these two will be perpendicular. So if this slope and this product is equal to minus 1, you will see that we have this condition, and this is already with us. So, alright, this into this should be equal to minus 1. If you open all the brackets, you will see that we have to satisfy this, and this is already with us. So that means we have proved that the two conics cut each other orthogonally. That is the end for confocal conics. I hope you understood everything. Rest of things you can read from the book, and practice exercise I will give the next video. Thank you.